Hello everyone, welcome to the next lecture on the CSIR Net Mathematics 2025. Today I will explain you how you can solve the problems related to the linear algebra. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the various videos related to the solution of the CSIR Net 2025. I had explained the complete paper with the help of the shortcut tricks. The last lecture you can see the linear algebra part B solutions, and you can see this is one of the easiest way you can solve the problem. I hope you can subscribe my YouTube channel. In this lecture I will explain you all those questions related to the linear algebra from the part C. As you can remember that I always solve with the help of the shortcut tricks. So before I start with this video, let me give you the one simple tips so that you can remember how you can solve the linear algebra problems. Always remember, whenever you will see the question related to the matrix, fine, always solve the problem with the help of the eigenvalues, or you can solve the problem with the help of the rank of the matrix. Then you can get your answer in the 15-second टाइम पीरियड. ऑलवेज हमेशा याद रखिए, जब भी क्वेश्चन में आपको मैट्रिक्स दिखाई दे, फाइन, हमेशा ही आइगन वैल्यूज और रैंक से सॉल्व करिए. फाइन, हमेशा करिए. यू विल सी, यू कैन सी द लीनियर अलजेब्रा पार्ट बी सॉल्यूशंस. अगेन इस लेक्चर में मैंने हर क्वेश्चन को मैट्रिक्स और आइगन वैल्यू से ही सॉल्व करा. फाइन, सो लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन. अगेन यू कैन सी दिस इज द मैट्रिक्स, so I can solve the problem with the help of the eigenvalues. A and B are the any two matrix. Then your target is to find the matrix M, which is defined as AB minus BA. Then which of the following statements are my true? Fine. Now जब भी आपको AB minus BA मिले तो trace of the M कितना होगा? 0 होगा always. Why? Because trace of AB is equal to trace of BA. Fine. तो इसका मतलब जब भी trace of the matrix 0 है, what does the meaning of that? The sum of the eigenvalues are my 0. So that means the eigenvalues of the M, can you find the eigenvalues of the M? Either both are my 0, or one value is the real, second is my negative of the real, or if one eigenvalue is my complex number, then other value is my also complex number. These are the eigenvalues of the M. Fine. Now check whether they are diagonalizable over R or not. So I can simply choose the one matrix M by any of the case. Let's say 0, 0, 0 and any value alpha. How? Because if I choose A and B are upper triangular matrix, then definitely M is also the upper triangular matrix. Fine. So I can choose here. So what is the eigenvalues? Eigenvalues are 0 and 0. So algebraic multiplicity of the eigenvalue 0 is my 2. Can you find the geometric multiplicity of the eigenvalue 0? It will be 2 minus rank of M minus 0I. So that will be, rank of this value will be my 1, provided alpha is a non-zero. So clearly say algebraic multiplicity is not equal to geometric multiplicity. So that means this is my not diagonalizable. So first option is cancelled. Look at the second option. A and B are diagonalizable. So again I can choose the same. I can choose say 1, 2, 3 and B is my 4, 5, 6. So clearly say they are diagonalizable matrix. Why? Because the eigenvalues are my distinct, and if you find the matrix M, again you will get M is my 0, 0, 0 and some number alpha, which is not diagonalizable over R. Fine. Now look at the third options. If A and B are the diagonalizable matrix, then there exists a real lambda, so that M will be lambda of I2. That means lambda 0 and 0. Again this is a matrix. So can you find the eigenvalues of this matrix? It is a lambda and lambda, but you can see the trace of this matrix is my non-zero, but we need a trace is 0. So that matrix is cancelled out. So that means the left option, that is a D option, is a right answer. How? you can see your target is to find the eigenvalue of the m square. So can you find the eigenvalue of the m square? It is a 0 and 0. It will be lambda square and lambda square. It will be minus of lambda square and minus of lambda square. Now, as per the given statement, m square is my lambda of I. So that means your eigenvalues are my. So definitely there exists a real lambda. Lambda belongs to R. It may be the positive, it may be greater than 0, it may be less than 0. So yes, this option is the correct answer of this problem. So देखिए कितना आसान तरीका था सिंपल मैट्रिक्स और आइगन वैल्यू से यूज करना. मैं उम्मीद करता हूं आप वीडियो को लाइक एंड कमेंट जरूर करेंगे. Okay, look at the second one. Again, this is the matrix, so I can start with the eigen's value. Can you find the eigenvalue of the matrix A? Eigenvalue of the matrix A is 1, 3. Can you find the eigenvalues of the B? Eigenvalue of the B is my minus 1, t. Then your target is to find the matrix AXB transpose. Can you find the eigenvalue of the B transpose? It is still minus 1, 5. Fine. Now, the first method, that's the shortcut tricks, is can you find the eigenvalues of the T? Because it's a product A into B transpose by the standard basis. Fine. So what is the eigenvalue of the A? 1 and 3. Eigenvalue of the B transpose is minus 1, 5. So the eigen's value of the T will be 1 into minus 1, 1 into 5, 3 into minus 1, 3 into 5. Now once you know the eigenvalue, can you find the determinant of this? That is the product of the eigenvalues. And can you find the trace of the matrix? It is the sum of the eigen's value. So you can see the A option correct, B cancel, C option correct, and D option cancel. So the right options are my 1 and 3 are the correct answers. Fine. This is the first method. There is one more method that you usually did in your examinations. Like you can choose a standard basis and then try to calculate the matrix by using A, X, B transpose, and then finally write the matrix 4 cross 4. But that is a very lengthy procedure. Fine. So always try to find the eigenvalues, and you can see by this method how many seconds you are needed to get the answer. I think you can get the maximum 15 to 25 seconds needed to get the answer. Comment करके बताइए whether you are interested to solve the problem by this shortcut tricks or not. Okay, look at this another one. Let V is the vector space of the real valued with the inner product here. Now if you read the statement, is the matrix word is written anywhere? No. So that means there is no need of the eigen's value. First option, whether it's a basis or not. Basis means your target is to check whether they are Li or not. It's a very simple. Can you write the cos x as a linear combination of the remaining elements? No. Can you write sin x, second pair, as a linear combination of the remaining one? No. Can you write the sin square x? I can write the linear, this is 1 minus cos square x. Cos square x is written, but 1 is not the part of the s. So that means it is Li. Also, you can write this number is 1 minus cos 2x over 2, and cos of 2x is not be written. Similarly for the cos square x. So that means you can never write any number in the linear combination of this. Therefore, yes, this is my Li. Fine. Or you can start with the alpha 1 sin x, alpha 2 cos x, alpha 3 sin square x, alpha 4 cos square x, and start with the 0 and try to prove that each of the alpha I are my 0. But that's a theory process. Once you are in the competition, just look about that. Is it possible for you that you can write as a cos square x is either of the linear combination of the remaining elements? It is not possible. You can write as sin square but 1 is not the part of. If it is already be 1, then it is not a Li. Fine. Now since it is a Li, so therefore this is my basis. Is it okay? Now look at the second options. Whether S is an orthonormal. What is the property of the orthonormal? Or orthonormal property means x, or I can choose as a f. That means f and f will be 1 and f and g is my 0. Is it fine? So let's start with the any number. So let's say cos x and cos x. Fine. What is the inner product of this? It's a 0 to pi cos square x. So by using the orthogonal property, this value is my pi over 2, which is not equal to 1. So second option is cancel out. Or how you can find this? अगर आपको orthogonal property का नहीं मालूम, then you can write this number is 1 plus cos 2x over 2, and if you integrate them, again you will get answer is pi by 2, which is not equal to 1. If S is an orthonormal basis. Now look at the third option. There exists f and g in the S such that the dot product will be 0. Yes, of course, again by using the orthogonal property, if I choose f is my cos or f is my sine, g is my cos, then by using the orthogonal property, it is my sine x into cos x. By using the orthogonal property, this value is my 0. Yes, there exists. Fine. Or otherwise you can use divide and multiply by 2. It is my sine of 2x. Then you can integrate them. It will be again 0. S contains the orthonormal basis, but it is not an orthonormal. So that option is cancelled. First and the third option are the correct answer of this problem. Look at this another one. For any variable x, consider the Q vector space and which are following are true. They are look about the dimensions. Very simple. If you watch my dimension of the vector space lecture, fine, then you can easily get the answer in a 5 seconds. अगर आपने अभी तक नहीं देखा, you must watch it and learn the concept. Firstly, I will check about the dimension of the A and B. What is the dimension of the V? How many unknown vectors are there? Unknown elements or unknown constants? 4. So dimension is my 4. Can you find now F? A is the mapping from V to Q. Fine. What is the dimension of the V? Dimension of the V is 4. Dimension of the Q over the Q is my 1. So therefore, dimension of the A is 4 cross 1. That is 4. So yes, third option is the correct answer. Can you find the dimension of the B? Now you can see B is the mapping of from the A. Dimension of the A is 4 minus, there is one restriction imposed on that. So 4 minus 1, that is 3. So second option is also correct options. Look at the last option. F belongs to the A. Then the image of the F is my one dimension. Fine. So look at that. How you can check about that? First of all, A is, if you look about the matrix associated with the A, let's say T of A, so it will be my 1 cross 4. Fine. Now whether it's a one dimension, if I simply choose is a linear transformation, if I choose this is the linear transformation in the A, then what is the image of the F? It is my 0. Fine. So it's a 0 dimension, but he said one dimension. This option is also cancel out. Look at the A option. If F belongs to the B, that means your target is to choose the pair or the value which is 0. So I can choose this number is 1 minus x. You can see f of 1 will be satisfied. Now clearly say dimension of the kernel is 3. If the dimension of the kernel is 3, that means nullity of the f is 3. That means rank of the f is my, dimension of B is my 3, 0, but it is not true. You can see that the rank is not a 0. So that means this option is also cancel out. So correct option is B and C are my correct option of this problem. I hope you can like and comment on the video as well. Now again you can see this is the matrix. So your target is to find the eigenvalue. So can you find the eigenvalue of the matrix A? हमेशा बच्चे पहले eigenvalue निकालिए, चाहे वो बाद में काम आए या ना आए. Fine. लेकिन हर बार निकालिए जरूर. Now you can see it has the 3 eigenvalues. Fine. Each row has the sum 1. So one eigenvalue is my 1. How you can find the remaining eigenvalues? So I can start with the A minus lambda I, which is minus lambda 0 1 1 minus lambda 0 0 1 minus lambda is my 0. So can you find the determinant of this? It will be lambda square minus 0 plus 1 1 minus 0 is my here. So that value will give you lambda cube minus 1 is 0. That means eigenvalues of the 1 is 1 omega omega square. Fine. Now clearly say, because all the eigenvalues are my distinct over complex number. Fine. So therefore A is diagonalizable over the C but not over the R. Fine. So both A and B are diagonalizable over R, but A is not diagonalizable. Fine. A is diagonalizable over C but not on the R. That's option is correct. Neither A nor B is diagonalizable over R. Okay. Neither A nor B is diagonalizable over C, but A is diagonalizable over the C. Fine. Now, how you can check about the eigenvalues of the matrix B? So I can write the eigenvalues. Can you calculate the eigenvalues of the B? So again, if you look about carefully, this is a similar, I can block them. Fine. So can you find the eigenvalues of the B? You can see, what is this matrix? This matrix is my A. So can you find the eigenvalues of this matrix? This is similar to the 1 omega omega square, and this block has the eigenvalues 1. So these are the eigenvalues of the matrix B. So clearly say these are the complex number, so they are not diagonalizable over the R. Fine. So that's why first option also cancel. Now how you can check whether they are distinct? A values are distinct, so they are diagonalizable. But how you can check about these two are my distinct? Algebraic multiplicity of the 1 is 2. Now I can find the geometric multiplicity of the 1. So that will be of the matrix B. So this is my 4 minus rank of B minus 1i. So can you find the matrix B minus 1i? So it is a minus 1 0 1 0 1 minus 1 0 0 0 1 minus 1 0 0 0 0 0. Fine. Now you can see I can add them. This value will be 0, this value will be 1. Fine. If you add them, this value will be 0 and this value will be 0. So what is the rank of this matrix? 2. 4 minus 2 is my 2. Algebraic multiplicity of the 1 is equal to geometric multiplicity of the 1. So yes, they are diagonalizable matrix. So A and B both are diagonalizable. That's the correct options. B and C are my correct answer of this problem. देखिए कितना आसान है, सिंपल आइगन वैल्यू से आपको सॉल्व करना है. Okay, look at this another one. A 4 cross 4 is a positive definite real matrix. What come in your mind for the positive definite real symmetric matrix? So you can simply choose the matrix I, which is a positive. Positive definite means all the eigenvalues are my greater than 0. Fine. Then consider the matrix B, which is defined like here. So I think it's a very simple, because I choose the matrix A is my I. So A, B, C, D. So this value is my I. It's a 4 cross 4. Fine. Now your target is to find the determinant of the B. So that means our target is to find the eigenvalues of the B. Fine. Or I can find the principal minors. Fine. Or how you can find the eigenvalues? I can use the principal minor. So first principal minor of the matrix B is my 0. Second principal minor will be 0. Second principal minor will be 0 minus A square. Third principal minor of the matrix B is a minus A square minus B square. This value is my 0. So it's a minus A square minus B square. Now you can see that all these, similarly for the fourth principal minor is my minus a square minus b square minus c square. All the principal minors are my less than equal to 0. What does it mean? This is my negative semi-definite. Once it is my semi-definite, that means eigenvalues or all the eigenvalues are my less than or equal to 0. Is it fine? Because it's a negative semi-definite, all those eigenvalues of the matrix B are less than equal to 0. Why is it 0? Because the first minor is 0. So once the eigenvalue is my 0, other values are my negative. So what does it mean? Determinant of the matrix B is 0. But the first option is cancelled, second option is cancelled. Fine. Now for the what value of the A, the principal minor of the second is a negative. When is a negative definite? For what value of the A can be any real number. Fine. So it has infinitely many pairs in which the determinant is a 0. Fine. For every pair of the ABCD, yes, for the every pair of the ABCD. So the right answer is C and D are my right answer of this problem. Fine. So that means you can get the answer of this problem because the principal is a negative semi-definite. All the eigenvalues are less than or equal to 0. So the determinant will always be less than equal to 0. So in this case, determinant is my 0. So the only case which satisfied is my third and fourth. Okay, look at this another one. Consider the variable x. Now this time is a real variable. Can you find the dimension of the v? There are the 4 variables. So it's a 4. Capital D is the mapping from v to v. So the dimension of the v is 4. This is also 4. So that means capital D is the matrix which is my 4 cross 4. Is it okay? Which is defined as derivative of the f with respect to x. So that's a very simple. Can you find the matrix? 1 x square x cube. For more detail, you can find the lecture of the linear transformation. You can find the lecture of this linear transformation and learn the concept. When you taken as a, so this value will be d of f will be partial derivative of the f with respect to x. So if you taken as a first is 1, the answer will be 0. The first column will be 0. If you taken as a x, derivative is a 1, that's a constant, it's a 1, rest values are 0. If you consider as the x square, derivative is my 2x, so it's a 2 into x and the rest values are my 0. X cube, then it's a 3x square, rest values are my 0. Once is a matrix, can you find the eigenvalues of the matrix D? What is the eigenvalues of the matrix D? 0, 0, 0 and 0. Fine. Now, look at this. M is a matrix from V to V. Again, it is my 4 cross 4. Fine. Which is defined as x into df. df matlab derivative of the f dash. So again, if you consider the pair x square, x cube. So can you find the matrix? If you taken as a 1, derivative is 0. If you consider as the x, derivative is 1, then it is my x, it is my 1, rest values are 0. X square, it is a 2x, it's a 2x square. 2x square, rest values are my 0. If x cube, then it is a 3x square, then it's a 3x cube. It's a 3x cube, rest values are my 0. Can you find the eigenvalue of the m? Eigenvalues of the m are 0, 1, 2 and 3. Is it okay? Now look at the first options. Second option, d plus m. Can you find the eigenvalue of the d plus m? 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3. Fine. Now you can see what is the determinant of the d plus m? 0. So but he said invertible. Cancel. Can you find the eigenvalues of the dm? It's a product. You can multiply them. 0, 0, 0, 0. So what is the determinant of the dm? Which is 0. So that option is also cancelled. Is it fine? Now look at the first options and last option. First of all, rank of the DM. So we all knows the rank of the DM is less than equal to rank of the M, minimum of the rank of D. Rank of D will be 3. Rank of this will be 3. So it is a minimum is 3. Also, we all knows the rank of the DM is greater than rank of the D, rank of the M minus number of the column vectors. So 6 minus 4 is 2. That means the rank of the DM lies between 0 and 3. Fine. Similarly, rank of the MD is also lies between 0 and 3. Fine. Now, how you can check about whether they are same or not? The last option is same and DM. So firstly, if you look about the DM, again it's a 4x4 matrix. Fine. Now once it's a 4x4 matrix, can you find the matrix multiply? This is my M. First row, first column, 0. Is it fine? First row, first column is my 0. First row, second column. Fine. This is my D into M. So I can write the matrix M here. First column, first value 0. This is my 1. First row, 0, 0. Fine. Now, second row, first column, 0. Second row, second column. Second row, third column, 4. Second row, last column. Similarly, for the last case, this is only the fourth position. So if you look about that, it's a 0, 0, 0, 9. And the last row is my complete 0. So the rank of the DM is my 3. Can you find the value of the M into D? Fine. M. So first row is a 0. So if you multiply the first row by the first column, 0, second 0, 0 and 0. Look at that, M into D, this column, row and each column, that is the second element. Look at the second element is a 0, second element is a 0, second element is 2, second element is here. Look at the third element. Look at the third element multiplied by 2. It's a 0, 0, 0, 6. And look at the last element, that's a fourth element. Multiply the last element by 3, 0, 0, 0, 0. So now you can see both the matrix are not same. Fine. Both the matrix are not same. And the rank of the DM. Rank of the DM is my 3. Oh, sorry. They are not same. They are not same. So that is a correct statement. Rank of the DM is 3. And the rank of the MD is my 2. And you can see both are not same. This option is cancelled. A is the only option which is the right answer of the problem. So आप देखिए कितने आसान तरीकों से सारे क्वेश्चन मैंने आइगन वैल्यू से ही सॉल्व करे हैं. फाइन. इसलिए मैं कह रहा हूं आप इस प्लेलिस्ट को देखिए, इन लेक्चर्स को सुनिए, आप मैट्रिक्स का देखिए, आइगन्स वैल्यू का देखिए, पीवाई क्वेश्चन ऑफ द आइगन वैल्यू को जरूर सुनिए. 55 क्वेश्चन है आपके पास. रैंक ऑफ द मैट्रिक्स को सुनिए आप. You can watch the lecture of the rank of the and many more lecture in this playlist. I hope you can like, you can comment on the video and let me know whether you enjoy this session or not. We will see the next lecture very soon on the real analysis because I already uploaded the rest of the lecture part C questions. Don't forget to share this video with your friends. Happy learning and please subscribe my YouTube channel. Thanks for the watching. Happy learning.